In this video, I'm going to show you how to create learning curves using multiple student modeling methods including AFM and BKT in a Tigris workflow. You can access the Tigris workflow tool by navigating to learnsphere.org in a browser. Click on Get Started Now or go directly to this URL in order to log in and get to the Tigris homepage. On this page, you will see all of your own workflows as well as other users' workflows as long as they've set them to public. If you go to the Recommended Workflows tab, you'll see a workflow called Comparing Learning Curve Models. The creator of this workflow set it to public, so we can see the structure of the workflow. We are also able to see the data in this workflow because the owner used public data from Datashop. If they used private data, we would not be able to see the data contained in this workflow, just the structure. We are going to recreate this workflow in this video. I'll create a new workflow. The list of various components in Tigris is found on the left here. If you hover your mouse over one, it'll tell you information about it. We're going to start our workflow as most others start by importing some data. I'll drag the import component into the workflow, then hit the gear icon to open its settings. In this options menu, you can upload a file that you have access to in Datashop from this list, or you can upload a file from your own computer. Today I'm going to analyze the geometry area dataset, which is publicly available in Datashop. The analyses we'll use in this workflow take student step data, so I'll import that file. Now that I've selected the file, it will be imported the next time I hit the Run button. Now I'll go back into the component menu to drag out the student model components. Under Analysis, you'll find AFM, Python AFM, and BKT. I'll drag these components into the workflow, then connect them to the import component. To stream data from one component to the next, click and hold on an output node, then drag your mouse to the input node of the component to receive the data. After dragging a new component into the workflow, it is always a good idea to first connect it to some data, then click the gear icon. The gear will bring up a panel that contains various parameters and settings for the component. In the case of AFM, we have the option to select which knowledge component model the algorithm should predict an error rate for. In this example, we are interested in the textbook model. When I click on the gear for BKT, I can choose the knowledge component model, but I can also set a number of other parameters, such as the BKT solver algorithm and the number of folds for cross-validation. The student model components will predict an error rate, then write it into a student step file. To visualize the error rate, we can use the learning curves component found in the visualization section of the component menu. Some input nodes for components can accept multiple inputs. The first node on learning curves can accept multiple student step files, and it will display all of the learning curves on the same plot. I'll attach the parameters XML file from AFM to the learning curves component. This will be used to categorize the learning curves. Once I connect the data to the learning curves component, I'll open the options. Important information about the component can be found if you scroll down. I want to use the textbook KC model. Because I have multiple student step files for this component, I'll select True for View Secondary. I can then select which KC models to use for the secondary models. The first number here indicates that this is a file header from a file attached to the first input node. The second number indicates which file is attached. Since we attached Python AFM second, it shows up as 1 and BKT is 2. Now that I've connected all the components and set the options, I'll click the Save and Run button. When it's finished running, I can double-click an output node, or I can click on the magnifying glass on a component to view the results. In the learning curves results, you'll see a plot for every skill in the textbook KC model. Each skill is categorized based on how much learning the algorithm believes takes place. The curves follow the order in which you connected the inputs to the learning curves component. So in this case, blue is AFM, green is Python AFM, and yellow is BKT.